We're going to take a look at slope fields. This will be the first part, and then we'll do the second part in a different video. A slope field is basically a pictorial representation of what's happening with rates of change and allows you to see what solutions to a separable differential equation is without solving it, just by looking at the graph of it. So let's take a look at an example. Let's say we had dy dx is x. Well, we've done this. We separate the variables by putting the dy's with the y's and the x's with the dx's and integrating those. And this is what we get when we do that. So this would be our solution to this separable differential equation, where this plus c would just represent a vertical shift upwards or downwards. So it'll take the graph x squared over 2, and whatever the plus c is, it's either going to move it up or down. Well, what if we couldn't solve it? This is where slope fields come in. We could draw a slope field to help us solve it. So if it wasn't a separable differential equation, we would use slope fields in order to solve it. So remember, rates of change is dy dx. So dy dx is known as slope or instantaneous rate of change, which is also represented as tangent lines. Okay, so just a quick recap. So we're going to go ahead and draw a graph, and we're going to place points or dots at each point. So the point 0, 0, draw a dot, point 1, 0, draw a dot, and so forth. So go ahead and pause the video and get that done, because it might take you a little bit longer than it takes me. Alright, then we're going to take a look at an example. Example 1, given dy dx is equal to x, sketch the slope field of the function. And we've already solved it, so we know what the answer is. However, I'm showing you how to use slope fields in order to do it. So we'll start off with an easy one, and then graduate from there. So the first thing you need to do is make a table, x, y, and then dy dx, which is equal to x. And basically you're just going to pick points. You're just going to pick random points. I always start with a point 0, 0, so I suggest, that's what you do. So when x is equal to 0 and y is equal to 0, so at that point right there, what's dy dx? Well, dy dx is x, so it's whatever x is, which is 0. So what does that mean? What does a slope of 0 mean? A slope of 0 means it's a horizontal line. And what you're going to do is you're going to draw a horizontal line just at that point, but not touching anything else. So kind of halfway to the right, halfway to the left. Let's pick another point. Let's pick the point 0, 1. So let's see what happens at 0, 1. So that's that point there. 0, 1, dy dx is 0 again, so it's horizontal. Let's pick another point, 0, 2. And we're going to see again dy dx is horizontal. So when x is 0, everywhere x is 0, it's horizontal, so I can go ahead and fill that in. So you look for patterns so that you can shortcut it a little bit. Let's pick another point, so 1 and 1, 2. Let's pick the point 1, 2. Well, dy dx is x, which is 1. So the slope here is 1. I'm going to come back to that one in just a second because I need a little more space. Let me pick another point, 1, negative 1. So plugging that in, dy dx is 1. So what does that mean? Slope of 1 means you rise 1 and you go over 1. So you start at that point and you rise 1, go over 1. And you want to draw that diagonal like it's going to join, but again, just a little bit to the right and a little bit to the left, like that. So that's showing you that it's 1 up, 1 to the right, because the slope is 1. Alright, so now we're going to pick another point, 1, 0. Again, the slope there is 1, 1. So you're going up 1, right 1, and then pointing the arrow in that direction. Let's pick another point. Let's say x is 2 and y is negative 1. So then dy dx, which is x, is 2. So what does that mean? It's 2 over 1. So rise 2, start at that point, rise 2, and then go over 1. And then you want to make the diagonal so that it looks like that. So this one's a little bit steeper than the one before. And all of these ones are going to be the same. You can kind of see a pattern that's happening. So you're just going up 2 over 1 and kind of lining it up. All right, let's do this other side. So let's have negative 1. Negative 1, negative 1. What's dy dx? Negative 1. So go to negative 1, which is that point, go down 1, right 1, because that's the slope. And you're going to line it up. And you'll notice that all of those patterns will be the same thing. Going down 1, right 1, down 1, right 1, because the slope is negative 1. Right? Finally, the other dots on the end, let's pick negative 2, negative 1. So the point negative 2, negative 1, which is right there, the slope of that, which is x, is negative 2. So you start at that point and you go down 2, right 1, because the change in y is negative 2 and x is 1. So you just join in, lining it up. So down 2, right 1. Down 2, right 1. Down 2, right 1. down 2, right 1. So something like this. So this one's a relatively easy one to graph. They get a little bit more complicated, so where you can't just make a pattern that quick. Let's say you're asked to graph the graph at y0 equals 1. So remember, 0 is your x coordinate, 1 is your y coordinate. You just go to that point and then you follow the wave, like how it's actually going. So go to the point 0, 1, which is right then. And what does it look like this graph is doing there? It looks like it's going to do something like this. So it's like you're just catching this wave, you're getting the general idea. Let's do it again. Let's say you're told to graph the graph at y negative 1, 1, sorry. So x is negative 1, y is also negative 1. You go to that point, negative 1, and you kind of just catch the wave with what's happening at that point. So it looks like it's going to be something like this. So again, it's not very exact, but you can kind of see the general shape that's happening. Now keep in mind, I said earlier that plus c just represents a vertical shift up and down, and you can see the graph is the same, it's just shifted up and down. This is a listening check. Circle example 2. So again, pause the video and you're going to make points. Let's do negative 3 to 3 and negative 2 to positive 2. Just points everywhere because we're going to fill those in with slopes, with tangents. Alright, this time it's x minus 1. I'm not going to draw a table because you're supposed to get good at this. So at 0, 0, right, what's going to happen? 0 minus 0 is 0. So that's a horizontal line. And then where else can you get horizontal lines? Where the x and y values are the same. So that's 1, 2, 1, 1, 2, 2, negative 1, negative 1. I'm just going to double check that one. Yep, that does become 0. And negative 2, negative 2. So all those will be zeros. Another point 1, 0. So that would be 1 minus 0, which is 1. So 1 up, 1 right. It looks like that. So we want to look for those ones as well. So where it's going to be 1. So 2, let's pick 2, 1. That's going to be 1, 1 up, 1 up. Let's pick, I'm going to pick the point 3, 2. And that's going to be 1, 1. Pick the point negative 1, 0. That's going to be negative 1 minus 0, which is negative 1. So this is 1 down, right 1. This is a listening check. Underline C right above the graph. Pick the point negative 2, 1. I'm going to draw it wrong, but listen to what I'm saying. Negative 2 minus 1 is negative 3. So it's going to be down 3, right 1. Make sure it's that steep. Negative 3, 2 is going to be negative 1. So that one's down 1, right 1. 0, negative 1 is going to be 0 minus negative 1, which is plus. So that's positive 1. That's 1 up, 1 right. Negative 1, negative 2 is negative 1 plus 2, which is positive 1. So 1 up, 1 right. Alright, 0, negative 2 will be 0 minus negative 2, which is positive 2. So up 2, right 1. 1, negative 1 is going to be 1 minus negative 1, which is plus. So 1 plus 1 is 2. So up 2, right 1. This is a listening check. Color in the first column of the table 0, 0, 0. 2, 0. So that's going to be 2. So up 2, right 1. 3, 1, that's going to be 3 minus 1 is 2, so up 2, right 1. That's 1, negative 2, so 1 minus negative 2 is 1 plus 2, which is positive 3. So that's going to be up 3, right 1. 2, negative 1, 2 minus negative 1, 2 plus 1 is 3, so up 3, right 1. I think that one's going to be up 3, right 1 too. 2, negative 2, that's going to be 2 minus negative 2, which is 2 plus 2, so up 4, right 1. That's going to be the same thing, that 3, negative 1, so it's be 3 plus 1, which is up 4, right 1. And I'm sure that one's going to be 5, 1, 2, 3, negative 2, yeah, that's up 5, right 1. So you can see the pattern that's beginning to happen. Alright, 0, 1, that's going to be negative 1, so down 1, right 1. 0, 2, that's going to be negative 2. Negative 1, 1, that's negative 1 minus 1, which is negative 2, so down 2, right 1. And basically just pause this video and keep plugging in the points and making the slopes. Just make sure you're doing rise over run to make sure you're exact, and then just compare your answers with me. I'll do a couple more. So that's negative 2, 0, so negative 2, so down 2, right 1. That's negative 2, negative 1, so negative 2 plus 1, which is negative 1, so down 1, right 1. Negative 3, 1, so that's negative 3 minus 1, which is negative 2, so down 2, right 1. That's negative 3, 0, so that's negative 3 down, right 1. Negative 3, negative 1, negative 3 plus 1, which is negative 2, so down 2, right 1. Negative 3, negative 2 is negative 3 plus 2, which is negative 1, so down 1, right 1. That one's 1, 2, so 1, minus 2 is negative 1, down 1, right 1. And so you see that there's a pattern that has begun to emerge. The important thing to know about this equation is that it's not separable. What does that mean? You can't solve it the way we did example 1 in the beginning, so the only one way you can do it is slope fields. So meaning you can't separate the x's with dx and y's with dy. So slope fields are your only option to find solutions for this differential equation. This is a listening check. Color everything I'm writing down in pink. Color everything I'm writing down in pink. Now you go with the wave, so I'm going to pick a point and just go with the wave, and you can see that this is pretty much what it does. Just picking different points. So these are all solutions. I'm just picking different points and going with the wave. And you can see that there's an isotope there. It never really touches. So all of these arrows are all solutions to dy dx equals x minus y. The graph of a solution must go with the flow of, what's actually happening. You have to get good at graphing these. The graph of a solution must go with the flow. And just remember that there is a isotope along this line right here. There's an isotope right there. No matter what the arrows are, they're never going to touch that line. That's pretty much all there is. Let's do part 2, but let's practice.